All right, so I guess we should have a blooper reel, but obviously my video is going to start with these first few problems done. Quick summation of the angle addition postulate we said was the sum of the smaller parts equals the whole, which is how we got that relationship there. Then the two following questions, we were given situations where in number one, we were given the measures of the two smaller parts, which allowed us to add them together to find the large angle, the whole angle. But then in the second one, we were given one of the smaller parts and the whole angle, in which case we had to subtract that from the total to figure out what was missing. So thankfully I caught myself this early in, otherwise I would have been sad. I'd have had to taught myself all alone later. All right, so number three. Number three says, if the measure of angle PQR equals 141 degrees, find each measure. So if we take a look here, PQR in this diagram is the big one. It's the whole thing. It is asking us to find everything that is missing, and it's actually labeled here on the right-hand side for us. And you'll notice X is the first thing at the top of that list. It's no coincidence, because in order to find the other angle measures, X is the key piece. So what relationship could we use, knowing that the entire angle equals 141, and we have these expressions for each of the smaller angles? What can we set up?
Plug in 141 in the X.
Not quite. So 141 is the measure of all of this right in here. So it's not just the X. The X is just a small piece in that big picture. Add the two together. So if you think about it, if you were to take away those expressions, if you were distracted by those, we could write the relationship that says that angle PQS, which is the left or more to the left part, plus angle SQR equals the big angle PQR. Hopefully that doesn't come as much of a shock. That's just the angle addition postulate, saying that the sum of the two smaller parts equals the big one. But then if we take a look, we actually have that information, or at least something for that information. So for PQS, we have the expression 13x plus 4. Adding to that the measure for SQR, which is 10x minus 1, equals the entire angle, the large angle, which we were told from the beginning was 141 degrees. So recognizing, again, setting up that relationship may be a key to setting up your equation moving forward. Now, which part you're looking for, that's going to change from case to case, but at least this gives us a place to start. So taking a look here again, quick side note, I'm under the assumption that since we are in geometry, I've said it a few times now, I'm assuming you've made it through at least algebra 1. As such, I'm also under the assumption that you can solve multi-step equations. So in those situations, once we get the equations set up, I'm going to go a little bit faster. But if I say or do something, or if you think I've made a mistake, or if you're just confused, let me know. But until you say, hey, I'm not sure how you solve that equation, I'm just going to go a little bit faster so you guys can focus on the new stuff. So taking a look at this equation, there's no parentheses, but there are like terms here on the left. Two sets, in fact. 13x and 10x are going to make 23x. And then 4 and negative 1 is going to make 3.
Right, so this
Solving the equations is like what we did yesterday, but the setup is different. Yesterday, we were looking at segments on lines and how the sum of those parts equaled the whole segment. So I guess you could say it's similar in the sense that we're still talking about the parts equal the whole. But instead of segments, we're looking at angles. Now, at this point, variables on one side, just got to get it by itself. So I'm going to subtract 3 from both sides. So it leaves me with 23x equals, was that 138? And then divide both sides by 23. 6. Okay. So we get x equals 6. Now, we're not done. It did ask us to find the rest of the information, but for the sake of keeping track of it, I'll write 6 over there on that answer line. But I am now ready to use that information to find the measure of angle PQS, which was the 13x plus 4, and SQR, which was the 10x minus 1. So off to the right here, I think is where I'm going to put mine. The measure of angle PQS is going to equal 13 times x, which I'm going to replace with 6, plus 4, which I believe 13 times 6 is what, 78, plus 4 should give me 82. So PQS is 82 degrees. And then from here, technically I have a choice. I could either subtract the 82 from the 141, because that would give me the other part that's missing, or I could plug the x that I have into that expression. So once you get towards the end of the problem, you start to have lots of options to choose from. Go with what you feel most comfortable. For me, I'm just going to go ahead and stay consistent here and use the expression we had for that angle. So 10x, so 10 times 6 minus 1. 10 times 6 is 60. Take away 1, 59 degrees. Which, assuming I did it correctly, 82 plus 59 equals 141, as it should. Those are the two parts. Should equal the total of 141 degrees that we were given at the beginning. Okay. I'm actually going to skip number 4. Were you trying it? I'm going to give you the answer. So go ahead and see it through so you can check as you go. But for number 4, if you work this one out, x, I believe, should be 10, unless I've made a mistake here. The measure of angle DEG should be 51 degrees. And the measure of DEF should be 74 degrees. Again, if you want to jot that down for now and practice that one later, knowing what the answer should be, by all means, that's up to you. Not a requirement, though. I am going to do number 5, however. Number 4 and number 5 are pretty similar to each other. That's why instead of doing 2 of the same type of problem, just going to knock one out. So number 5 says the measure of angle JKM, which is this smaller one towards the left, is 43 degrees. The measure of MKL, which is the other part, we've been given the expression 8x minus 20 degrees. JKL, instead of being given the whole measurement this time, is also an expression. So we still want to find each measure. So you'll notice we still need to find that missing variable. But to do that, we're still going to use the angle addition postulate. And in this case, if I was taking a look at the diagram here, I could say that angle JKM plus angle MKL has to equal the big angle JKL. Only difference here is, well, really not that much of a difference. What we're dropping into those positions are just different values or expressions. So going off of the information we have listed up above, and again, if you're not sure what I'm talking about, I'm saying we've got this information, this expression, and this expression, all of which have a corresponding location in this relationship. So JKM is 43 degrees plus MKL, which is the expression 8x minus 20, equals the measure of angle JKL, which is 10x minus 11. And just like that, I have an equation that I can start walking through in order to solve. So going into algebra mode here, no parentheses. I do, however, see some like terms here on the left with that 43 and that negative 20, which I believe is going to give me 23. So 8x minus, excuse me, not minus, 8x plus 23 equals 10x minus 11. That takes care of the like terms. I then notice that my variable is on both sides. Usually in my algebra class, I recommend moving the smaller of the two. So I'm going to subtract the 8x from both sides. Takes it from the left. So I have 23 equals 2x minus 11. And then I just work towards getting that variable by itself. So I'm going to add 11 to both sides. Twenty-three plus 11 is going to give me 34 equals 2x. And then last but not least, I'm going to divide by 2. 17. So I get 17 equals x. Which I'm going to slide over here, put that there for a reminder. Ask you to pardon my mild OCD as I pretty this up a little bit. Zoom it out there. So good news is we found probably the most, I would say the most important piece, because with x now, we can start dropping them into these expressions to find the missing information. So for example, let me split my work here. Try to stay as pretty as possible. So the measure MKL, we're given the expression 8x minus 20. So we'll have 8 times 17 minus 20, which I want to say is 80 plus what is that? 50? 136. And then 136 take away 20. 116. And then the last one here, angle JKL, going to be 10 times x, which is 17, minus 11. So that's 170 minus 11, which is 159. Good. So in terms of complexity, or at least the algebra that it uses, is pretty straightforward. The only reason it may seem more challenging is because we were finding multiple things. Once you found one bit of information, you then broke out and did little sets of work later. But in terms of complexity in algebra, we're just solving equations. So in reality, the only new part is setting up that equation initially. And to do that, we need to know the relationship. And this has been just the angle addition postulate so far. Any questions on this page? Yes. Sure. So moving on to the next page. Again, just to preface this, I'm going to do number 6 with you guys. I'll give you the answers to number 7, but I'm going to probably recommend for your own sanity, we're not going to worry about number 8. It adds an extra layer of algebra 1 that I don't want you to worry about right now, and that's not something that I would test you on either. I'm more interested in the relationships and then applying those relationships, not tricking you. So we'll do number 6. I'll give you the answers to number 7, and then we will probably do, I don't know, maybe one of the ones down below as well. All right, so number 6 says if angle DEF is a straight angle, the measure of DEG is 23x minus 3, and the measure of angle GEF equals 12x plus 8, find each measure. So again, our goal is going to be identifying this relationship. So sum of the parts equals the whole, which means angle DEG plus angle GEF is going to equal the whole angle, which is angle DEF. Oops. So we are given an expression for DEG. So that's going to be 23x minus 3. Add to that our expression for GEF, which is 12x plus 8. And that's going to equal, well, now I'm stuck. Maybe. Didn't just come out and say what the measure of angle of DEF was. How do you know it's 180?
Because a straight angle is 180.
Absolutely. So there's lots of ways to refer to it without spoiling the circle unit we have coming later this term. Yes, a straight line, if you identify it as an angle, is 180 degrees. So that was something we mentioned 2 days ago, I think, as well in one of our notes. So the key word here that allows us to come to that realization is the word straight angle. So I'll say off to the side here that every straight angle is going to be exactly 180 degrees. So I'm going to drop that value into my equation. And then just like the previous ones, I go into solving mode. So no parentheses, thank goodness. I do have like terms here on the left-hand side. 23x plus 12x would be what, 35x? -3, +8 gives me 5. Equals 180. Now to get that variable by itself, I'm going to subtract 5 from both sides. Give me 35x equals 175. And last but not least, divide both sides by 35. Five. So x equals 5. So over here on the list, x equals 5. Then using that information, we should be able to find some of these other missing pieces that we're looking for. So DEG, we had an expression over here.
3 times 5 minus 3
So DEG equals 23 times 5 minus 3.
equals 112.
Good, so 112 degrees. And then GEF is 12 times 5 plus 8. So what, 68? What about measure of angle DEF? $180. We already said it earlier because it's a straight angle. But if I had forgotten that, could I have added the two smaller parts? I still would have gotten 180 degrees. It's good. Number 7. I'm actually going to do one little bit better than just give you the answers. I'm going to give you the starting point and the answers. Everything in between, I'll let you work through, because on this one, it says the measure of angle TUW, which is the upper part, is an expression. WUV, which is the smaller part, is an expression. But then TUV is also an expression. So the angle addition postulate would tell me that the measure of angle, TUW plus the measure of angle WV would have to equal the measure of angle TUV. That's why I'm going to give you there, because I think you guys could drop in the expressions in their respective locations. But then if you do want to try this one now or later on your own, the answers you should get is you should get 7 for X. Angle TUW should be 38 degrees. WUV should be 65 degrees. And TUV should be 103 degrees. Again, that's up to you if you want to see that one through using this angle addition postulate to get you started. Give you a second to write that down if you want, before we jump down to number 9. I would say, if anything, if you're gonna get tired of anything in geometry, it's probably gonna be writing letters. Because pretty much everything we identify in a diagram uses letters in one way or another. So that just gets a little bit tedious. All right, numbers 9 and 10. Let's see here, is using the same diagram. For number 9, it's telling us, let me find it here, the angle ABF, which is this angle that's opening, it's pretty large, opening kind of down and to the left, has an expression. It gives me an expression for angle EBF, which is that very small angle. And it gave me the measure of angle ABE, which actually includes both of those smaller parts, before it then asked me to find the measure of ABF. So again, if I'm going angle addition postulate, the relationship based off of that diagram is as such every time. Angle ABF plus angle EBF is going to have to equal the big angle ABE. So that helps me in the diagram recognize which ones are the parts and which one make up the whole. From there, I can then just come back here to my expressions and start dropping in those values, finding what I need, going from there. So ABF, we have the expression 6x plus 26 plus EBF, which is 2x minus 9, equals ABE, which is 11x minus 31. So like terms first here on the left-hand side, I've got 6x, I've got 2x, which gives me 8x. And then I've got 26, take away 9, which I believe gives me 17. Equals 11x minus 31. Then I want to get the variables to one side, so I'm going to move the smaller of the two, which is the 8x, by subtracting it from both sides. Leaving me with 17 equals 3x minus 31. Then getting the variable by itself, I'm going to add 31 to both sides. So that's what, 48 equals 3x. And then shame on me, I didn't plan ahead for space. So dividing both sides by 3, I get x equals 16. Am I done? No, it did actually ask for the measure of angle ABF. Thankfully, we have that expression here. So we would say ABF is 6 times x, which is 16, plus 26. 6 plus times 16 is what, 60 plus 36, 96 plus 26, 122. Cool. I guess if I was being a stickler here for detail, technically I wouldn't want to fully box in that x because it was just a means to an end. It wasn't actually my answer. It was just used to get to my answer. And the last one here on this page, number 10, also using the same diagram. It's giving me some information here, more so than I'm used, or in a different format. First thing it says, it's asking us to assume that ray BD bisects angle CBE. What does it mean to bisect? Go through it, but in a very specific way. Straight down the middle, cut in half, the two halves are equal. Yeah, cuts it right in half. So BD bisects CBE. So CBE is right here. BD is this ray. Now, because it is asking us to assume now, in my diagram, I'm going to say that this angle and this angle must therefore be congruent. Because to cut in half means that the two halves must be equal. So that's thanks to that first statement. The next statement says, again, I showed you the symbol, maybe we've forgotten. It says that ray BC, this is the perpendicular symbol, BC is perpendicular to BA. So BC and BA are perpendicular, which means what? What do we know about perpendicular intersections? Give you a clue. The corners of this room are perpendicular intersections.
90 degrees.
They are exactly 90 degrees. Perpendicular intersections are always exactly 90 degrees. So I'm going to draw a little box there in that angle, because if they are in fact perpendicular, if they're perpendicular, they form a 90-degree angle. From there, they gave us lots of information. They told me that CBD, which is one of those parts, is 3x plus 25. So I'll squeeze this in here, 3x plus 25. And DBE, which is the other part, is 7x minus 19. So just to make them pop a little bit, I'm going to highlight those so we can see them in there. So again, that is just coming from the prompt from number 10. So I'll leave that there for just a second. If you're jotting it down, following along here with us, the goal is to find the measure of angle ABD. Now that's interesting because ABD is right here. Do we already know part of ABD? Which part do we know? We know that part of it is 90 degrees. What we're missing is this piece in here. CBD, we need to find angle CBD so we can add it to the 90 degrees. But in order to find angle CBD, whoops, we're also going to need to find X. X is key. Is there a relationship you guys can see here where we could set up an equation? You said 3x plus 25 equals 7x minus 19. How do you know they're equal? Congruent? So we said earlier they are congruent. That's why we put that notation in there, because we were told that it was being bisected. So we, from the very beginning, already drew in some information that allows us to say, oh, these two parts are equal. So down here in my workspace, I'm going to set them equal. 3x plus 25 equals 7x minus 19. And then I'm going to solve. So no like terms. Variable is on both sides, however. So I'm going to subtract 3x from both sides. That gives me 25 equals 4x minus 19. Add 19 to both sides. I believe that's 44. Equals 4x.
11.
Divide both sides by 4, I should get 11. Now, is that what I'm looking for?
No.
No. What do I still need? Or what did that help me find? Maybe I should say. I can put it back in where? One of the two. Well, it might make sense, since we know it's part of what we're looking for up here. It might make more sense to plug it in for CBD, even though they're both the same. So it's up to you. But if I know what angle CBD is, that's going to get me one step closer. So angle CBD is going to be 3 times x, which is 11, plus 25. So 33 plus 25. What was it?
58.
58? Is that what we were looking for? So gotta follow with me here. We found the x, which led us to find angle CBD, but we're looking for angle ABD, which includes another 90 degrees with it. So angle ABD equals the 90 degrees that we clearly defined plus angle CBD, which we just calculated. So 90 plus 58, 148. Good. And now we're done. That deserves a definitive box. So we had to find the X to find a missing angle that we then added with another angle to find a larger part. So as you can see, the difficulty most likely is going to come from just the level of organization. Now, if the worksheets I give you ever crowd you out and you don't feel like you have enough space, use some lined paper. I've got grid paper up there too, if you'd rather, but use extra paper. I don't need you to try to cram it in there just because I gave you such little space. All right. Switching gears a little bit, we're going to quickly talk about different angle relationships. We've mentioned these a little bit before, but they're going to have some direct application for us here on the following pages. I'm going to work my way around this diagram a little bit faster because, again, it should be a recap of Tuesday's notes. So vertical angles are two angles across from each other on intersecting lines. They are always congruent. So the diagram I'm going to draw here is going to be two lines just intersecting. Mine kind of looks like just a regular old X. I'm going to label the angles with values. And then I can say, because they are in fact vertical angles, I would say that angle 1 is congruent with angle 2, and angle 3 is congruent with angle 4. So 1 and 2 are vertical, 3 and 4 are vertical. I'm gonna go clockwise. I'm gonna slide over here to linear pair. Linear pairs are two angles that are adjacent and supplementary. That's my bad. I'm about to use one that I haven't defined yet. Pause on that. Supplementary angles. Supplementary angles are any two angles whose sum is 180 degrees. Now they could be adjacent. That's not always necessarily the case, but I would probably say that it's going to happen more often than not. But what that means is the sum of the two angles, if they are in fact supplementary, should equal 180 degrees. That's a very specific example. It's one of infinitely many that are out there. Rewind back up to linear pair and write a diagram that's slightly more generic. So I'm going to use kind of the same diagram as below, but instead of giving specific values, I'm going to name them angles 1 and 2. And according to that statement, angle 1 plus angle 2 has to equal 180 degrees. Moving on around past supplementary angles over to complementary angles. This is any two angles whose sum is 90 degrees. So I'm actually going to cheat a little bit here. I'm going to draw in a right angle, a 90-degree angle. I'm going to prove that it's a 90-degree angle by drawing my little square there in the corner. And then from there, I'm just going to kind of split it, not necessarily in half, because that's kind of boring. We talk about bisectors quite a bit already. I'm going to kind of split it there and say this larger part is angle 1. This smaller part is angle 2. So based off of the statement up above, we would say that angle 1 plus angle 2 equals 90 degrees. And that is because they are in fact complementary. And then the last one here on this diagram, adjacent angles. We've actually have been seeing several adjacent angles as we move around this here. It's just any two angles that are next to each other and share a common side. So just going to draw an obtuse angle here. And put a third ray there in between them. So we would say angle 1 and angle 2 are adjacent. They share a side. I don't know if I can fit it all on. Kind of hard to see it all, but there's everything. Again, these are angle relationships. Think of it as some common vocabulary we're going to use anytime angles come up, because some of these facts become very helpful when you're looking for missing pieces. Now, to try it out, we have these 6 scenarios here. We're going to identify by comparing angles 1 and 2, which of these categories they fall into, whether they are adjacent, vertical, complementary, supplementary, or linear. Now, they may be more than one. Are angles 1 and 2 adjacent? No, they'd have to be side by side. Are they vertical?
Yes.
Sure are. Do we have enough information to say that they're complementary?
No.
No, because we'd have to be able to prove they added up to 90 degrees. Do we have enough information that they're supplementary?
No.
Still no way to prove that they equal 180 degrees. Are they a linear pair?
No.
No, because if they're a linear pair, what does a linear pair mean? Usually it means, if you think about it, in order to be a linear pair, they actually have to be both adjacent and supplementary, which we already said it was neither. Number 2, angles 1 and 2, are they adjacent? Do they share a side?
No.
Careful, don't get distracted by that little box there. Angle 1 and angle 2
Yes.
are right up against each other.
Yes.
So they're adjacent. Are they vertical? No, usually vertical lines, imagine drawing an X, they are the opposite angles from each other. Are they complementary?
Yes.
How do you know?
Because of the little square box that's right there.
Well, now hold the phone. We'll challenge you here real quick. That box says that this angle here on the left is 90 degrees. It doesn't say anything about these.
But it cuts it in half. Oh, man.
You're getting there. You're on the right track. Are you looking at this bottom line down here?
No, I'm just looking at 1 and 2, 90-degree angles.
Yeah. Well, we don't know this is 90. We know this is 90.
Oh,
But can I ask you a question?
why can't how
we-
come that's not 90 though?
It is 90, but I want us to defend. I want us to understand why it's 90. Look at this line here at the bottom. What is the measure of any straight angle?
180.
180. 90 is accounted for here. That leaves me with only 90 for the other side as well. So you were right. I never said you guys were wrong. I just wanted to make sure you guys knew why you were right. So they are in fact complementary, which means there's no way they could be supplementary. You can't equal 90 and equal 80 at this 180 at the same time. Are they a linear pair?
Yes.
Ooh. Don't get distracted by the whole thing. 1 and 2 just exist over here. Do those two angles by themselves form a line?
No.
No. All 3 of these angles form a line, but 1 and 2 by themselves do not. Good. Number 3. Are these angles adjacent? Side by side? Do they share a side? Yeah, they share this ray right here. So they are adjacent, which I'll tell you, if you have adjacent angles, they cannot be vertical. Are they complementary? Meaning they add up to 90 degrees?
No.
No, because I have a sneaking suspicion you're going to say yes to the next one. Are they supplementary?
No.
Well, look at how, so that can we agree they're adjacent, side by side?
Yeah.
So they're side by side, they share one of their sides, but look at their other 2 sides. What does it form? It forms, well, actually, it can answer the next 2. It forms a line, which makes them a linear pair, because then therefore they must also be supplementary. So again, this will take some practice. It's some vocabulary that fools you from time to time. Number 4, are they adjacent? Side by side, attached?
No.
Careful, if you're ever unsure of whether or not they're adjacent, look at where the angles are. If in tracing both of them, you trace one of those rays twice,
Yes.
they are in fact adjacent. But again, if they are adjacent, they cannot be vertical, because vertical are going away from each other. Do we have enough information to say they're complementary? No. And even if you tried to argue to say, well, it almost looks like it might be kind of sort of 90 degrees. Is close enough in geometry? No. You have to have definitive proof, or at least a way to prove that it's true. So not complementary. No information to tell us that they're supplementary either. There's no way they're 180 degrees, which means they can't be linear either, because in order to be a linear pair, you have to be adjacent and supplementary. Ooh, this is getting messy. Number 5, it's got some distractions in there for you. Don't let it fool you. Are they adjacent, side by side?
Yes.
Not quite. Missy, I want you and I need to work on some of these 101, because you consistently answered the opposite on each.
Yeah.
So somewhere in the definition of adjacent, we're getting something flipped there. But at least you're consistent, which tells me you're not guessing. There's just a misunderstanding. They're not adjacent because they're not sharing a side. They're sharing their vertex. They're not sharing a side. Are they vertical? Some of you are saying no, and I think I know why. This line, oops. This line right here is distracting you. Try really, really, really hard to pretend that that line's not there. As angle 1 and 2 in an X,
Yeah, they're vertical.
they are vertical. That's going to be one of the hardest things in geometry, is not getting distracted with the extra fluff. They are vertical. Do we have any proof that they are complementary?
Yes.
I'm intrigued. How do you know? I'll agree with you.
Square.
Okay, okay. But the square is not angle 1, but there is a way to, there's a way to defend this answer.
If there's a 90-degree times that by 4, that would be what, 360?
Okay, so you're saying if this is 90, and since these 2 here are lines, that must mean that these are all 4 90s, right?
Sure.
Okay. It appears that this 90 has been cut in half based off of these little notations here. What's half of 90? 45? Well, let me ask you this. If angle 1 is 45 degrees and 1 and 2 are vertical angles congruent?
Yes.
They are. So 45 and 45 make 90. It's a very long roundabout way to get there, but the frustrating part in geometry is you have to take that path. Because as soon as you leave open a possibility where someone can post an argument, you then have to go back and defend yourself. So when you make it airtight all the way through from beginning to end, no argument necessary. They are in fact complementary. Last one here, 1 and 2, are they adjacent? No, they're not sharing a side. Are they vertical? They are. Here's another sneaky one. Are they complementary? You sure? Is the square what's making you think complementary? So the square does tell me there's a 90-degree angle in there. But here's the thing, if that is 90 degrees and it is adjacent to angle 1, for instance, and they form a line, that must mean if this is 90, angle 1 is also 90. So 1 by itself is 90, which is vertical 2, which is congruent. So they're both 90. 90 plus 90 is 180. So it wouldn't be complementary. It'd be supplementary. So each of them by themselves are 90 degrees, but when you add them together, they're 180. And then the last one there, are they a linear pair?
Yes.
Not quite. And the clue there, in order to be a linear pair, if you want to, I think it's on the previous page, they have to be two things. They have to be adjacent and supplementary. These are just supplementary.
Okay.
It's a unique thought exercise. Really no math, no calculating involved, just identification. All right, we're gonna do a handful of these, not all of them. If you're curious later as to what the answers are, I can share those with you as well. But we're gonna try to pick out the relationships, or excuse me, pick out the missing information, but then defend our answer by describing what relationship we used. So for example, we'll start with an easy one here at the start. Anyone know what x equals? What's it? Why do you say 112? If it helps, I'll tell you you're right.
180, okay. So each line, I guess you could say each line is 180
Okay.
degrees. So, yeah.
So very quickly in your head, did you say, well, if 112 and this have to equal 180, then this number plus this also has to equal 180, which must mean this is 112 as well. That is a good way of thinking about it. I've got a shortcut for you. These are vertical angles. All vertical angles are congruent because they got the same vertex, but they're going opposite away from each other. But what you said wasn't wrong. Took a few extra steps, but everything you said was absolutely true. And you could do the calculations there to prove it as well. What about number 2? I heard 90 minus 68. Okay, I like what I'm hearing. What does that give you? 22. And where'd the 90 come from?
Right angle, square.
Yep. So the whole thing is 90. You take away the part that you know, which is the 68, and what's left is what you don't know, which turns out to be 22. What about number 4? Number 4 is a little sneaky because there's an X, Y, and Z. It is just trying to throw you off. If you went in alphabetical order, though, the 43-degree angle and angle X should equal what? 180. So X should equal 180 minus the 43 we already know. So X equals 137. And I'm actually going to stop you right there on that one because we technically now have enough information for all of them. Because if you look at it, the 43-degree angle and our angle measured in Y are vertical, so they are congruent. The measure angling X, I'll do this one, and Z are also vertical, which means they're congruent. So X and Z are the same. Y must be 43. I get a little giddy with these. I enjoy these because I find them to be a relaxing thought exercise. Now, I imagine if I thought, well, this is an assignment and it's going to be attached to a grade, maybe it's not so relaxing then. But if I was just doing it because I chose to do it, I find it relaxing. I'm actually going to jump down to number 6 as well. This one just no diagram even says angles 1 and 2 are vertical angles. If the measure of angle 2 is 105 degrees, find the measure of angle 1. It would be the same. What was the key word that told you that?
Vertical.
They are vertical angles. Vertical angles are always congruent, which means they are equal to each other. So angle 1 equals 105 degrees. Let's see. I don't want to bore you with too much of the details here. I'm going to skip down to the last section here just so we can get some of that variety in there as well. We'll do at least number 10. Number 10 reads, if angle PQT is 3x plus 47, so since this is the only diagram for this one, I'm going to actually squeeze it in there. I'm a very visual learner. And SQR is the expression 6x minus 25. Find the measure of SQR. So very clearly, we're going to need to find x first to be able to figure out SQR. But what relationship can you guys spot that would allow me to set up an equation?
What was your question? I'm sure.
Well, so any relationship that you can pick out with angle relationships that would allow you to set up one equation. PQT.
So, am I supposed to be just saying the equations?
If you have the equation for me, that's fine. But it may even be easier. Just look at the angles we have. Is there any kind of classification from one of those previous pages we could use to say, hey, I know how these two angles relate to one another? So PQR is 180 degrees, but the downside to that is I know nothing about TQR, so I wouldn't have enough information to set up an equation. But then Missy, I heard you claim they are congruent, but I need you to defend that answer for me. How do you know they're congruent?
And I put a line on top and then on.
A little arc thing. That would identify them visually that they're congruent. But how can we say that that must be true? What type of angles are they? They are vertical angles. So vertical angles are always congruent. So in this case, they are equal to each other. Therefore, 3x plus 47 must equal 6x minus 25. And get the variable to one side, subtract 3x from both sides. Gives me 47 equals 3x minus 25. Add 25 to both sides. So 4, 5, 6, 70,
72 divided by 3.
72. You said divided by 3. What'd you say it was?
Sorry, you're right, it's 72
Okay,
divided by 3.
I think is then gives us 24.
Yeah.
But be careful, we are not actually looking for x. We are looking for a missing angle. In this case, SQR. Which equals 6x minus 25. So 6 times 24 minus 25. You said the whole thing comes to 144?
No, minus 25 is 119.
So 144 minus 25, 119. Cool. So I know some of you are thinking, oh gosh, there's still multiple types of questions on this page. There are. They recycle a lot of the same vocabulary. So some big takeaways, really probably the biggest takeaways. Vertical angles are always congruent, meaning they are equal to each other. So if you're having trouble spotting vertical angles, that would be maybe your first stop to focus and see, can I spot vertical angles? Complementary angles, what do they add up to equal? So complementary is 90, supplementary is 180. And then a linear pair is extra special because not only are they adjacent angles, they form a line, which means they are also supplementary. So you have a lot of the notes here for you. I'm going to get you access to the worksheet here. It's just one sheet of paper. It is two-sided, but it's pretty much straightforward. It's a lot of the same relationships recycled.